Chapter 3.2 Mains Electricity and Household Wiring. Let's begin. Be an electrician. With just one battery and one light bulb, you can easily form a closed circuit. However, when the rated current of the bulb, which is 2A, flows through each wire, the wire is overloaded and overheating may occur. The wire will burn as a result. So, can we use these thin wires to allow 2A current to flow in a closed circuit? 1. Alternating current. A battery drives a direct current, or DC, which flows in one direction only. The current driven by the mains is an alternating current, which changes its direction periodically. The potentials of the terminals interchange periodically, and the direction of the current changes accordingly. 2. The mains circuit. The two terminals of the 220 volts mains are called live and neutral. The potential of the neutral is always 0, as it is earthed. The potential of the live changes between positive 311 volts and negative 311 volts, with a frequency of 50 Hz. A standard AC cables have 3 wires inside. The live wire, which is brown in color, neutral wire, blue, and the earth wire, green and yellow. The AC generator at the power plant changes the potential of the live. However, as the neutral is earthed also at the power plant side, so the potential of the live changes between positive and negative potentials. So why the neutral is earthed at the power plant side? Because the earth may provide a path to complete the circuit. The current driven by the mains is a sinusoidal current. It has a frequency of 50 Hz and a period of 0.02 seconds. In this way, the current changes its direction 100 times per second. When the live is positive, current flows from live through the appliance and back to the neutral. When the live is negative, on the other hand, the current flows from neutral through the appliance and back to the live. 3. Safety designs in domestic electricity. A. Fuse. A fuse is just a short length of thin wire, which should be placed in the live. The fuse should allow the rated current of appliance to pass through, but break the circuit when excess current flows. The fuse will melt when excess current flows, which overheats the fuse. When the fuse melts, it breaks the circuit and stops the current flow. Fuse is cheap and it can be readily replaced. The fuse protects the electrical appliances from being overloaded and also prevents the cables from being overheated by excess current flow.
Let's gradually increase the current and see what happens. The bulb glows brighter as the current increases. When the current exceeds the rating, the fuse gets hot. The fuse melts at last, and the electricity is cut off. Let's test if the bulb is damaged. Thanks to the fuse, the bulb is still okay. Now you see how the fuse works.
There are different fuse values for appliances of different rating currents. We should always use a fuse value slightly larger than the rated current. For example, An appliance of rated current 2.5A should use a 3A fuse. An appliance of rated current 11A should use a 11A fuse. In this way, the fuse will melt very soon when excess current flows. Example 7. How many microwave ovens can be connected? There are a lot of microwave ovens in our tuck shop. We cannot simply connect them all to a single 13A socket. A 800-watt microwave oven has a rated current of 3.64A. So we can at most connect 3 of them to the 13A socket. In fact, we connect only 2 to the single socket at the tuck shop, as the power of some microwave ovens are higher than 800 watts. Example 8. Positions of fuse and the switch. The fuse and the switch must be placed in the live wire. When the fuse is broken or the switch is open, we can be sure that only a short length of the live wire is still live. And we are sure that the appliance and most parts of the circuit are not live anymore, which means that it does not carry a potential, so that the user will not get an electric shock when they touch the appliance. On the other hand, if the live or switch is connected in the neutral wire, when the fuse is blown or when the switch is open, a large part of the circuit is still live, which means carry a voltage from the live wire, and hence it is dangerous. When someone touches this part of the circuit, which is supposed to be safe, this current flows through that someone and he gets an electric shock. C. Double insulation. Appliances with an insulating case do not need an earth connection. Since the live wire has an insulating plastic covering and the appliance has an insulating case, this is called double insulation. Hair dryers are usually made of plastic, and so they don't actually need an earth wire. However, the EMSD of the government insists that the appliances with double insulation still need an 3-pin plug, as the plug is more secured and thus less easy to get loosened from a socket. D. 3-pin plug and socket. A 3-pin plug in Hong Kong has an earth pin slightly larger and longer than the other two. The earth pin is slightly longer so that the appliance is earthed at once. The earth pin is also used to open the shutters of the live and neutral holes of some designs of socket, which is a safety feature to avoid children accessing the live hole. The 3-pin design also avoids plugging in the wrong direction and also provide more secured connection, so that the plug does not get loosened too easily, as compared with the 2-pin plug in the old days. Exam link 2. Circuit arrangement of different output powers. This is quite a standard question, with 2 resistors to provide high and low power, usually one by connecting them in series, and the other by connecting them in parallel. Note that when the supply voltage changes, the resistance of the appliance does not change. The output power is V squared over R when different voltages is applied. Do check point 3 on the next page.